Good morning and welcome to Thursday, April 23rd. This is AP Statistics. Today I'm going to review the one prompt that I gave you to practice for the Chapter 11 optional test. And then I'll also post some additional information in the Google Classroom for how you can best start your preparation for our AP exam. The prompt gave you a story in which we have a big box store, kind of like, let's call it Home Depot or Sam's Club. We have the store in Kingston, and it serves 4 different regions of the city. However, the store is placed not central to the city. So they want to know if all 4 regions of the city are being served appropriately. And what they gave you was a breakdown of the north, south, east, and west quadrants of the city of Kingston. And they told you the proportion of people that live within those regions. So that's how it started off. And they said that based on their calculations, roughly 40% live in the north, 24% live in the south, 22 in the east, and 14 in the west. The question was, is the store serving the 4 regions of Kingston appropriately? If they are, we should see the relative proportion of those patrons coming in from those 4 regions. Now, they say that we take a sample of 250 people. I'm going to extend this little table. And we're told first that there's 250 people. Okay, so my N is 250. And they give us the observations. So of the 250 people who come into the store, they ask them their question, what region are you from? Turns out 120 are from the north, 48 from the south. We get 62 in the east and 20 in the west. All right, so that's all well and good. Now the question is, run the appropriate test to see if the big box store is serving all 4 regions appropriately. So I guess the first question is, what kind of test is this going to be? We already know, obviously, it's a chi-square test, but is it going to be goodness of fit, homogeneity, or independence? Well, we have a distribution of what we expect to see. It's one variable, the region from which they come. It's clearly a goodness of fit test. We want to see how well our distribution of observations fits with what we would expect on that one variable. So it's a goodness of fit test. Wouldn't hurt to identify that chi-square GOF. That's fine. In a goodness of fit test, what is the null statement going to be? Well, in this case, the null is simply going to be that all 4 regions of the town of Kingston are being appropriately served. So I'll just shortcut that with all regions served. I wouldn't say equally, because it's not equality we're looking for, it's whether they're served proportionally. So we'll say all regions served proportionally. Making the alternate statement pretty simply that not all regions are served proportionally. And if it turns out that they're not, we can say specifically where we would think a new store should be open. That was the overall question, is should they open a new store, and if so, where? All right, I have my null and my alternate. I understand it's a goodness of fit test. There were 250 people that were surveyed, and I have the breakdown of where they're from. But now the question is, what did I expect to see? So, if I know that, let's say, 40% of the people come from the north, how many of the 250 people did I expect to see? Well, I'm going to show one little calculation. The expected value of, let's just say the north, so a little subscript of n, equals the 250 people times the 40% that are supposed to come from the north, and that gives us an expected value of 100. And then I'll do the ... the little ellipsis to say that I'm going to keep doing that to find the rest of the expected counts. Okay, well, I've got 100 people in the north. Now, if I find 24% of 250, well, that's 60 people. 22% of 250 is 55 people. 14% of 250 is 35 people. At this point, we can also verify the conditions for the goodness of fit test. The first condition is that we have a simple random sample. It did say that we had randomization in our sampling. That's great. Another condition is the 10% rule. There's 250 people surveyed, so are there at least 2,500 people that could have been surveyed? Yes, of course there are. And finally, the expected counts rule. Are all of the expected counts at least 5? Turns out the smallest one in my distribution is 35, so yes, that does adhere to the minimum of 5. All of my conditions have now been met. And I would write that down if this were a prompt for me to solve, but I, of course, am concerned about my space. Okay, chi-square values come next. Now, the chi-square value for each cell is the same equation every time we do a chi-square value. So we'll just example the north. It's observed minus expected squared over expected. So it's 120 minus 100 squared divided by 100, and that's 4. So my first chi-square value is 4. And we move on. If you do the same thing, 48 minus 60, quantity squared over 60 is 2.4. And for the east, it's 0.8909. And for the west, it's 6.4286. All right, and that's the distribution of values that I need. So all those numbers are very important numbers. The next thing I need is my chi-square total, where you just add up all the chi-square values. Now for this distribution, it is 13.7195. Degrees of freedom in a goodness of fit test are the number of categories minus 1. Well, there's 4 categories, the 4 regions of the city. 4 minus 1 is 3. Next, we use our chi-square CDF from a lower bound of 13.7195 to the infinite bound with 3 degrees of freedom. The p-value I get here is pretty small. It's 0.0033, which is less than any alpha. I know that there wasn't an alpha given to you in the prompt. We used the typical 5%, but 0.0033, it's not going to matter. It's lower than any common alpha level. So what happens when your p-value is very low? You can reject the null. Specifically, we're rejecting the null that all areas are proportionally served. Now, in the previous worksheets, you were asked about a follow-up analysis. We're still going to do a follow-up analysis. When you reject the null, you want to actually say why it was rejected, other than the large chi-square total or the small p-value. That's not what I'm looking for. I'm looking for the actual inference here. So if I look at my data, I see that I have a relatively large chi-square score for the north, relatively large chi-square score for the west, a moderate one for the south, a very small one for the east. What it meant is the east is being served proportionally. The value that I observe and the value that I expect were very close to each other, giving me the very small chi-square score. But the west has the largest chi-square value. And if you look at the data, I expected 35, but I only saw 20. It's being underserved. Also, the north has a next largest chi-square score. I expected 100, but I got 120. The north is actually being overserved. There's plenty of people from the north. The store is probably located in the north region. The south, I expected 60, I got 48. It's also somewhat underserved. So my guess is that this store is probably in the northeast, and we need a new store. Where should it be placed? In the southwest area of Kingston. That's going to give us the best results. It's going to serve the underserved population. That's the result they're looking for. It's not enough to simply say, reject the null, areas aren't being served proportionally. You have to actually give it the inference, otherwise there's kind of no point in the analysis in the first place. Understood? Okay, great. Now, there's no additional work tonight other than to review the processes, because tomorrow I'm going to post a very shortened chi-square test. Again, it's optional for those who want the extra credit. However, if you're not doing the optional work, then I expect you're doing some sort of review for the AP exam. It's coming up on May 22nd, and we're all going to take it on that day. It's going to be 2 free response prompts, and that's it. So start your review. We can look towards the AP Central websites for advice. I'll certainly start providing the best review and advice starting on Monday. Have a wonderful day.